really excited about your presentation is that you've been doing these tours of North Africa with this incredible inflatable, the bubble, yeah, like it's a venue, it's an inflatable venue. And you've been going to Morocco and Tunisia as part of the Franco-Tunisian project, No Logo, which is now EFest. And so you're basically touring, doing interactive installations, projection mapping, and also at the same time doing TouchDesigner workshops and other workshops with the Berber people and other people. And I imagine it's like a really nice two-way education. Anyway, I'm very excited, so thanks for joining us today.
Can you hear me? Yes, better. So hello everyone. First I'd like to thank the TouchDesigner team and Hovo for making this great event happening. I'm really excited. So I'm gonna start by introducing myself a little bit. So I'm Vincent, or Tajnini, it's nickname. I come from a background in the engineering school. I did electronics and computer science. I'm into music since very, very young. So during my studies, I quickly started to tinker with Max MSP, processing, finding ways to make images with music and playing with this stuff. And in 2017, I actually discovered TouchDesigner while I was trying to use a Kinect. So that was my first foot into TouchDesigner, and from this time I haven't stopped. Got stuck into many very interesting tunnels. So thank you, I really love this software. So today we're gonna talk about few TouchDesigner projects I've done in Maghreb these last few years. Since 2018, I'm working with Franco-Tunisian collective by the name of Eco Electric. So during the 5 past years, we were doing a project called No Logo. The idea of this project is to bring interactive medias into remote areas of North Africa. So we toured extensively through Tunisia, Morocco, Algeria, making tours. So how it happens, it all started with getting in touch with art school or engineering school, local school, in remote areas like small cities generally. And it all started with workshops. So TouchDesigner was really great for bringing multimedia interaction to these people because its nodal thinking allowed me to easily bring the engineering students into visual art conceptions and the artist students into the logic of computer science and programming. So that was really nice to have this tool. Also, the free licensing of TouchDesigner allowed these people to have it for free, keep playing at their home after the workshop. So the idea of this project is really planting seeds in remote territories, and I want, after, if my workshop is a success, these people, they keep on tinkering on TouchDesigner. That's the idea. So whole started with workshops in schools. Each tour starts with that. And then, oh yeah, I forgot to start there is pictures coming on. So this is the bubble we're touring with. It's inflatable, it's very convenient. Because when you deflate it, it's just like that. And you can tour in a small truck. So we just go on public places and with 2 hair blowers. And well, what is difficult is like you have to spend 4 hours putting sand in bags to put it all around. And this project is very like collective way of thinking and doing. So there is no like artist or roadie. Everybody helps everybody. So it's very tiring, but also very interesting. So you start the tour with sands all over your body generally, and then you try to set up the stuff you imagine for this tour. So this place was actually a really nice space of experiment for me. I had a lot of liberty, and every year I think about a new field, which will be maybe an interactive installation, maybe a performance, maybe a scenography device, and then I give workshops where I teach how well, these results drive the workshops, and it's a pretext to explore different worlds. And well, generally it's with TouchDesigner. This last 4 years I was doing TouchDesigner workshops, which sometimes it was video mapping, sometimes it was controlling LED strips, using the capacitive effects, generating sound. Sometimes we connected it with Arduinos to make many experiments, many interactive stuff. It's a really great space for that. And so recently, I'm going to talk about the last project we've done. We moved from no logo, which was a kind of multimedia circus we were moving through. So there was a lot of constraints of time and setting up. It wasn't a black room. You had low time constraints to put up your complicated stuff. So we've decided to bring back the other format, which was called EFest. It actually was before No Logo, but I wasn't with them at the time. The EFest set up in the fixed place. So in April we went there. Well, that was the first EFest with the public in April of this year. This is the gate of the Ksar El Fersh in the southern Tunisia. It's like the door to the Sahara. It's very desertic. It's near Tatooine. It's where George Lucas shot Star Wars. It's this kind of environment. So we started this project 2 years ago, started to think about it. And at the time, we wanted to make international video mapping open call. So over the Ksar El Fersh, which is really huge. So my job was to make a 3D model of the Ksar El Fersh in order to lay out the video installation and to produce a UV map for the artists to start their creations. At the time, just the year before, we were here, which is in Djerba. It's called Mosquée El Fadloun. This was my first architectural projection mapping, which is, well, this architecture is, let's say, simple in front of Ksar El Fersh. So at the time, I could do all with just a laser range meter and take my measure, make the 3D model by hand. Actually, I did use the Kinect V2 at the end while setting up the final projection, because all of this is made by hand with traditional materials, so no line is straight at all. All the domes are just like that and like that, so I just use few point clouds of the Kinect V2 to refine my calculations. So I'm just gonna, yes, so this was like the result, few caption of that. It was actually a full real-time 3D TouchDesigner project, but we're not gonna dive into that today. So let's get back to the Ksar El Fersh. So this was 2 years ago, starting to thinking, okay, I'm gonna make a 3D model of these huge things. knowing that all these projects are public funded, everything is free. So basically, we are very, very low budget, and we have to find solutions. That's where TouchDesigner really helped me. So I was in front of that and thinking, okay, what can I use? So I think about photogrammetry, I think about 3D scanning, but like we totally can't afford a LiDAR for 3D scanning. But I think about last year when I used the Kinect V2 to take few point clouds and think to myself, okay, maybe I can make a lot of point clouds and build something to merge all these point clouds together and build a chip solution for 3D scanning. And I was looking for the Kinect Azure, so I got my hands on it. It was nice because the depth sensor was a bit better than the V2, and the RGB camera was also nice. So my idea was, well, at the time I haven't done any photogrammetry or 3D scanning in any project before, so it was new to me, and it was like a good opportunity to, well, I wanted to try both techniques because I was wondering, is photogrammetry reliable enough to lay out a complex video mapping? Is it possible to merge 1,000 point clouds of Kinect Azure with TouchDesigner? So I've decided to do both and to compare methods. So this was, oh yes, so this is just a quick reminder for people if you forgot. Like photogrammetry, you do it with a classic RGB camera. It's based on parallax, so you take your thing from different points of view, and then you can use special software with algorithm, which can then produce a 3D model. When you do 3D scanning, generally it's what we call the depth camera. So instead of RGB pixel, you have X, Y, Z, which are really coordinates in space. And if it's a complex architecture, you have to take a lot of captures, and then the work is about merging all these point clouds together to produce a huge point cloud. So LiDAR does it by itself, but it's just too expensive. So I tried to do it by myself with the Kinect Azure. So this was my little setup in the middle of the XRL First. So it's pretty simple, just a tripod, a Kinect Azure, and my computer on battery. Actually, well, we're gonna talk about it afterwards. So I've built a little TouchDesigner software, which was really simple. It was just to be able to take 2 captions at a time. Like when I hit a key, I take a capture from the RGB camera and the capture from the depth camera. So in the end, I have both of them, and after I can maybe use them, I hope, at that time. So I'm gonna show you a little bit of this patch. It was like that. So the idea is I was moving through and taking captures. So like on the right side, it's from the RGB camera, and on the left side, it's from the depth camera. I just was running around with my tripod, my computer like that. Well, a friend was holding the tripod and was like that. And we couldn't see much because of the sun. Oh, that was funny. There was a lot of dust also. Oh yeah, just like quick reminder also, point clouds from the Kinect Azure. It actually gives you 7 channels. So these were like the RGB channels mapped over the XYZ position, which has then. So this is XYZ represented in red, green, blue, which does something like that. So this is like the special representation of this point cloud with the color of pixel you can use for texturing. Really nice. Yep. So yeah, I did a lot of these shots, been going. So As you can see, each shot has a lot of overlapping, because the idea is to find similarities between point clouds to be able to merge them together. So you have to give it a big overlap. All right, so well, this is some of them, but yeah, actually took more than thousands of shots, and it took me 3 days because the sun in the desert was so strong, it was totally beating the Kinect sensor. Like, so I only had the 2 hours before the night when the light was good. So yeah, to do it for 3 days, and yeah. So in the end, I had all these shots, hoping I found a solution to make a 3D model out of it. Yeah. So this was the capture. So now, so as I said, I've got all these RGB shots and all these deep depth shots, and I want to compare both techniques, so using RGB shots for photogrammetry and depth shots for I don't know how now. So I've started with photogrammetry. I tried lots of software. Actually, the one I had the best result by far was Metashape. Just like that. So this is just few shots, just a part of the XR. So here you can see each point is like an estimation of the camera position. And this is the mesh Metashape generated afterwards. What's interesting here is I actually combined photogrammetry with point clouds to have my results in the end. So what's nice in the Metashape is, like, as I said, all these things are like camera point of views. And in Metashape, if you do something like file export, export cameras, you can generate a file .change, which TouchDesigner loves. You can just drop it into TouchDesigner, and it gives you a chop with all the channels and the different camera position and angle. It's very nice. So, which leads us to the second batch, which is here. So here's all the camera shots with X, Y, Z, here X, here Z. I imported. So yeah, this is my interface. Here I can just specify my scan folder and the Metashape folder, and then it loads automatically. Like this is the OBJ generated by Metashape, which I will use as a reference for merging my point clouds together. And so now I can just generate instance cameras from this file. So let's make some cameras here. So here I'm actually creating TouchDesigner cameras at the positions inferred by Metashapes. So I can go faster, make 10 of them. All right. Well, we're not gonna go that. We're just gonna go till there for the example. Okay, so all of that are point of views. So now I can move through the cameras here. So on the left side, it's just the view of the 3D model from the camera. And on the right side, it's the point cloud we're trying to register. This is my registration software. Oh, I totally forgot to talk about something before, which was my inspiration to go in this path. It's actually something released by Darian Brito, which is called TD-A0 Major. I think some of you know him. He made this TouchDesigner patch to allow you merging multiple Kinect Azure together and to have complex point clouds in real time. It was looking like that. Like here, you got two Kinect Azure. It's not registered now, so the point clouds are separated, but in the end, they're going to blend together. For that, he used the Open3D library, which is a Python library, open source Python library. It's specialized in the 3D data. There's a lot of nice things into it. what interested me was that, all the 3D data processing algorithms. Here I actually need what we call the registration algorithm, which are algorithms, their job is to find similarities between point clouds and to put them together. I remember on the Moski I showed you before, I was on my screen like that, killing my eyes trying to put the point clouds together by hand. It was a pain. I spent the whole night doing that. Hopefully there were just 6 point clouds. And so now I can do it anymore. So yeah, the idea is to use Open 3D registering algorithm. It's a whole subject of research because it's used in autonomous cars, and so there is a lot of papers around that, many different algorithms. So Open3D have a lot of them, which works very well. And yeah, it's quite easy to set it up. Just you have to install the same Python version as your TouchDesigner's version, and then you just install Open3D, and then in TouchDesigner you can just import Open3D if you specify the right Python installation folder in your parameters. And so yeah, so that's what I did here. So at first I tinkered with the Darian Brito's Azure Kinect merger, and then I decided to do it from scratch because there was a lot of new functions he wasn't using and stuff I'd like to try. So I did that, and I've got 5 minutes, so I'm gonna go a bit faster. So just a quick example. So for example, here we can downscale the point clouds because you don't need that much resolution for registering. It's better to remove points and just voxelize them. So I'm not gonna voxelize it, but this allows to do that. And then I'm gonna set up, gonna start a registration. So I'm gonna set up a start point like that. I'm gonna create it here. So this is my first point cloud, which is gonna be the targets, and then I try to register other point clouds following tag, tag, tag. So now, if I create the second point cloud, it's gonna be, so right now it's not good, but I can use like a global fast, which now it's kind of good, and generally you refine it with like ICP color is the one working well. All right, and then so we can go faster and just add them with enter. It register automatically. Can refine them and all the way. And yeah, so yeah, I could keep going. So in the end, you can just merge all of them together to get like a final point cloud, which looks like that. This is actually downscaled version, so there is not much. Well, I don't even know where is it. Yeah, whatever. But the file is like only 80 megabytes, so it's pretty, yeah. Because yeah, you have to remove the noise and stuff like that. I haven't talked about, and all the similar points. So I got how many time now? 6 minutes. Okay. All right. So what are we gonna talk about? We have a lot to talk about. Yeah. Quickly, fun project. This one, another one, something totally different. We wanted to make interactive video mapping following motorized panels. We were in Tunisia. There weren't any rotary encoder, which is something we use generally to know the rotation of your panel. So we went to the library and we found a toy car for child. We used this wheel, built that over like a car. I don't know how you say that in English. The car. Yeah, windshield. So it's a windshield wiper. We found motor, and this is like actually an optical wheel I've built with the designer. This optical wheel. and there is like a infrared emitter and receptor. So on the black it doesn't come back, and on the white it comes back. So then you can have pulsations and your angle. So in the end, I was doing. So I was like driving the motors with TouchDesigner through Arduino, and I had like, yeah, my wheel was telling me where I was, so I can stop the motor. The idea was to synchronize the video mapping projection with the panel. So yeah, everything was driven with TouchDesigner and textured. So it wasn't perfect, but almost could be perfect if you take time to set it up. And yeah, in the end, we had like it's 2 minutes 53. Okay, yeah, okay. That sound. No sound, yeah. I think. Oh yeah, maybe. It's just. So yeah, in the end, we built like 5 panels of that for the scenography of a performance I was doing. This is inside the bubble. Yeah, just so you know, the system of mapping following, we couldn't use it because of the time constraints. I haven't had enough time to set it up, so finally we just projected. But this was a TouchDesigner project, generating the visuals through real-time audio analysis from my synthesizer controller, and driving the panels through audio analysis, like synchronized to the beats, stuff like it was moving the content and panels. That was fun. Actually burned my sound card on this gig because the electricity there is, we can't hear much. And yeah, quick 30 seconds inside before leaving, because I said I will be talking about DOM projection. I will not, but just to let you know that I was able to set up a DOM projection video mapping with TouchDesigner using Cam Snapper over itself. So I had 4 video projectors with 3D model and mirrors, and I was making my video projector thinking, well, using Cam Snapper over the image of the other one, and yeah, I managed to do this kind of DOM projection. That was fun. All right, thank you.
Very inspiring. Thank you so much, Taj. I just love how you're using such low, just the bare minimum technology and found things and just reusing things. So that's really, really nice to see and beautiful work.